In order to find our derivative here, we can take some inspiration from what we did yesterday. Remember, yesterday we did the derivative of inverse sine of x. And we actually showed out the long way to do it. We started by actually solving our first equation into something that looks a little bit easier. Now, how can I get rid of log base 2?
2 to the y equals x.
Yeah, I can turn it into exponential form. So yeah, that's going to be 2 to the power of y equals x. Now that is something that we can find the derivative of. And so in order to find this derivative, you now have to remember the rule that we learned for the derivative of an exponential. Of course, we know from long ago that the derivative of e to the x was just e to the x. The derivative of 2 to the x, so let's actually write that over here. The derivative of 2 to the x equals 2 to the x ln x. Oh, I'm sorry, not ln x, ln 2.
Oh, they said 2 to the y.
And so if I'm going to find the derivative of 2 to the power of y, that means it's going to be 2 to the power of y ln 2 times the derivative of the inner function. Because we're doing chain rule here, with y being our inner function. So it's going to be times y prime. And that equals the derivative of x, which is 1. Well,
Flip everything.
now we got to then divide both sides by 2 to the power of y ln 2.
Oh, that makes sense.
So it's just 1 over 2 to the y ln 2.
So can you just
And
simplify
then
that 1 over 2 to
The
y?
last step, once we've divided both sides by the 2 to the y ln 2, remember 2 to the y equals x. And so I replace the 2 to the y here with x here.
That makes sense.
And we then have a rule. We figured out what the derivative of log base 2 of x is.
Is this another derivative rule?
And so yes, we are going to need to put this into our derivative rules. Now, in this case I use 2 as my base. But you can see that no matter what number we choose that to be, it's just going to follow down and end up in that spot in the equation. And so then this goes on to your derivative rules page. So it seems like we've gone through basically all the function rules at this point. Now we got logarithms, although there is something related to logarithms that maybe we should put down as well.
Exponential.
What would the natural log of x give us as a derivative? And actually, we don't even need to do a whole bunch of work. What would that be? Well, of course, remember, natural log of x equals log base e of x. So if it's log base e of x, that means a is e. So what's the natural log of e?
Oh, 1.
1. And since the natural log of e is 1, that means that whole natural log part on the bottom will go.
1 over x.
So it's just 1 over x. Alright, so we're going to find the derivative of this one. So I'm looking for y prime. Now notice we got a chain rule situation. We have sine of x plugged into the function of natural log. Well, first thing we do is we do the derivative of the outer function. So that's the derivative of the natural log. We just saw that is 1 over whatever's on the inside of it. So that's going to be 1 over sine of x.
It'll just be secant x then.
But
What do you have to
this isn't done yet, right? It's chain rule. I still got to multiply this now by the derivative of the inner function. What's the derivative of sine? Cosine. So that's going to be times cosine of x. Well, this cleans up, doesn't it?
Oh.
Cosine over sine?
Oh.
That would equal cosine of x over sine of x. Which, again, that also cleans up a little bit. Cosine over sine equals cotangent. And so this whole answer just ends up being cotangent of x. So now to find this derivative, notice it's another chain rule situation because we have log base 7 of e to the x. So if I was putting parentheses in, that's where they would go to show that the e to the x is inside the log. So to find y prime, we're going to be doing 1 over whatever is inside of our logarithm, so that's e to the x, But notice this one's not natural log, it's log base 7. So we're also going to have ln 7 in the denominator. But now we're not done. Because remember, it's chain rule. So that's the derivative of the outer function. Multiply that now by the derivative of the inner function. Well, the derivative of e to the x is just e to the x.
So then it's just 1 over ln
7.
Clean it up. So that means we got an e to the x on top, and it's over e to the x ln 7. And you notice the e to the x's do cancel out, so y prime is just going to equal 1 over the natural log of 7. All right, so to find this derivative, we're doing log base 2, so that means it's going to be 1 over whatever's on the inside, so that's going to be 3x squared plus 2x. And then that's going to be times ln 2. Now, you want to be careful when you write it, though, because if you wrote it that way, that's not right. Because remember, the whole thing is times the natural log of 2. So keep those parentheses around your polynomial here. And then times the derivative of the inner function. So times the derivative of the 3x squared, which is going to be 6x, plus the derivative of 2x, which is 2. And again, if you wrote it like this, that's not right. Because this is only multiplied by the 6x. Put the parentheses around it. All right, and then from here, y prime is going to equal 6x plus 2 all over the 3x squared plus 2x times natural log of 2. Can't I simplify that at all?
9.
Well, is there anything that I can divide out of every term in top and bottom?
No.
Well, the only thing I can pull out of top is 2, because there's not an x in the 2 term, so I can't pull any x's out. I could divide both those by 2. Can I divide the bottom by 2?
No.
No, not really, because ln 2 can't divide that by 2, because the 2 is trapped inside the natural logarithm. And I can divide this by 2, but I cannot divide this by 2. And so this is actually our final simplified answer. It's as good as it gets. So when doing this problem, we want to find the tangent line, which of course means finding the derivative. So if I'm going to find y prime here, I got to find the derivative of x squared times natural log of x. But what rule am I going to have to use here? Yeah, product rule. Because it's x squared times the natural log of x. So that means original times derivative plus derivative times original. Now, let's go ahead and clean it up a little bit before we go too much further, because you'll notice here the x squared times 1 over x, that would just be x. And then plus 2x natural log of x, well, that one doesn't really simplify at all. So that's just going to be 2x natural log of x. All right, now that we've gotten to this point, we've found our derivative. Now figure out what is your slope of your tangent line. So to find your slope now, I'm going to go ahead and call it m. I want to plug the value of x back into x in this equation. So I'm basically taking the 1 from the coordinate pair that I have up above. So if I plug 1 in, I'm going to do 1 plus 2 times 1 times the natural log of 1. But the natural log of 1 is 0. And so that whole thing just ends up equaling 1. I now know my slope, which means I know that my final equation is going to be y equals 1x, or just x, plus something, plus b. Okay? Now, solve for b. All right, and so from this point, I plug 0 in for y, 1 in for x, solve that out, and we end up finding that b equals a negative 1. Therefore, your final equation, y equals x minus 1. And we're done.